Again, good afternoon, everyone. This is a continuation of what we had discussed last meeting. How are you doing there? Grade 9?
Good job.
Okay. I'll be sharing my screen. I'll be sharing my PowerPoint presentation. We are now into dihybrid cross. Di means two or more. And by the way, let's move back to monohybrid. Any questions with monohybrid? Okay, any questions?
No, sir.
Nasabtan ra?
Roger.
Okay, just to make it clear, because the next topic could be dihybrid, so it's more complicated than the monohybrid. When you say dihybrid, this is two or more, okay? Meaning to say that you are crossing now is a cross between two different lines or genes that differ in two observed traits. Meaning to say that um, you are now crossing two alleles or genes in a particular organism. Like for example, this one. We are crossing a round wrinkled, round and wrinkled, and yellow and green. Okay, these are the alleles, two different alleles. So either ways that an organism has a round shape, which is colored yellow, and a wrinkled shape, which is colored either yellow or green. It depends upon the organism. Meaning to say that these are two different alleles mixed in an organism. We are actually composed of different alleles. That is why. Now, cross? How can we use the dihybrid? Um, in dihybrid, you need to cross multiply first, or you need to, you know, um, use the monohybrid setting first before getting the uh, actual phenotypes at the same time genotypes. Like for example, the cross between a heterozygous round. Are you still with me?
Yes, sir.
Okay. A cross between heterozygous round and heterozygous round with heterozygous yellow to a heterozygous round again and heterozygous yellow. So what would be the result? Okay. Sure. Where did they get this? Can you see my cursor? Can you see? No? Are you still with me? Can you see my cursor?
Yes, sir.
Yes,
Okay.
sir.
No, sir. Other.
You cannot see
Yes,
the
sir.
cursor? My cursor
I
ba?
can see na, sir.
Was it
We
clear?
can see na, sir.
Okay, okay.
Yes.
Sige. How can we cross this one? Simple. By crossing again, if you need to remove this one, the entire alleles. Diba this is 4? This is, um, if you're going to look at this one, you can cross this one using a monohybrid setting, right? Are you still with me?
Yes,
Okay.
sir.
These
Yes.
Yes,
variable,
sir.
these are the variables, or these are the genotypes. Okay. So you cannot directly, copy this one directly. No. In crossing dihybrid, you need to cross first the entire allele or the two genes, this one, in a monohybrid setting. So I'll be sharing my screen. I'll be sharing the Word document. So we're looking at the uh, heterozygous round and heterozygous yellow. Okay. Can you see the word? Grade 9, can you see the Word document? I mean,
Yes, sir.
okay.
Yes.
Yes,
Since
sir.
you're now
Yes, sir.
crossing, oh, by the way, why you didn't told me that the activity sheet was not there? It was not there. Okay, your activity on on dihybrid and monohybrid. Upon checking, it was not there, so I uploaded it back.
I just I just account, sir. Explain it, sir.
You didn't inform me that the activity sheet is not there. Next time you inform me that, sure, the activity sheet was not there. So what should we do? Okay, that's why I'm
Yes, sir.
asking also if you just upload a screenshot from your phone explaining the monohybrid and dihybrid. No, those are the exercises um, that you'll be taking in order to practice the monohybrid and dihybrid cross
Can
match.
we still take, sir?
What?
Take the con, sir? Can we still take the quiz, sir?
Yes, yes, of course. Yeah, I'll be just explaining the dihybrid. Okay. Now we are again. Diba I told you when you cross dihybrid, you need first to get the two alleles in the parent side and cross by itself. So we are now crossing a heterozygous round and heterozygous yellow. Correct? Correct? Hello?
Yes,
Yes,
sir.
sir.
Yes,
Okay.
sir.
So again, cross the heterozygous. Again, cross the heterozygous round. Are you still with me? With heterozygous yellow. Okay. And the results are round yellow. Have you seen the result?
Yes, sir.
Okay. So the result are capital letters RY, small letter R and Y, a small letter R and capital Y, capital R and small letter Y, and all small letter R and Y. So if you're going to observe the results, these are your variables or these are your um, possible phenotypes, possible genotypes rather. So I'll be sharing my screen back to the PowerPoint so to double check if our variables are correct. Okay. Okay. Did we match the variables? Grade 9?
Yes, sir.
It is not matched.
No, sir. It's not.
Huh? So I'll be sharing back the Word document. You look at the variables, capital R and Y. So it's in there, capital R and Y. How about the second one? The small letter R and capital Y. Let me check. Small letter R and capital Y. It's in there, right?
Yes.
Yes, sir.
Okay.
Yes, sir.
Next, capital R and small letter Y. Going back to the slides. Capital R and small letter Y. It's in there. Yes. And the last one is small letter R and small letter Y. So let me check on the PowerPoint. So it's in there, correct? Grade 9.
Yes, sir.
Okay, so meaning to say that our variables are correct. So we successfully cross the two alleles. The purpose of crossing the two alleles in a monohybrid setting for us to get the variable to get the different phenotypes and genotypes to spread the entire genes, because we are not just crossing a single genes here. We're talking about two or more alleles or two or more genes. Please look at your diagram or illustration. We are crossing now a heterozygous round, heterozygous yellow to a heterozygous round and heterozygous yellow. The results are one
Oh,
one homozygous. This is homozygous, right? All capital letters.
yes.
Homozygous round
And
and what is
two
this?
heterozygous.
This is homozygous yellow. Okay. Again, one homozygous round to a homozygous yellow.
And
Two homozygous round, homozygous round and heterozygous yellow. Okay. Two. So one, two. Okay. One homozygous round green, one homozygous round. Okay. Homozygous round green. This one. Can you identify
yes,
now? Can you see the difference?
yes, sir.
Two heterozygous round with homozygous yellow. Two heterozygous round. Okay. Heterozygous round
Round green.
with homozygous yellow. Okay.
Ah,
Where is the heterozygous round with homozygous yellow? Where is it in the illustration? When say heterozygous round and homozygous yellow. Hmm? Heterozygous round. Have you seen? Can you check it on your screen? Grade 9. Can you still
Heterozygous round only, sir.
heterozygous round with homozygous yellow. So one,
Heterozy-
one.
take a look at my cursor. Can you see my cursor?
Yes, sir.
Okay. This is heterozygous, right? Capital R and
Yes,
small letter R. Correct? And this is homozygous, right? Yellow, all capital Y.
Yes, sir.
Okay.
Yes, sir.
So one and here's the second
two.
one. Here's
The
the second one.
quadrant. Heterozy.
Here. You look at my cursor. Okay, heterozygous round and homozygous yellow. Have you seen my cursor?
Yes,
Yes,
sir.
sir.
Okay. Four heterozygous round and heterozygous yellow. Four heterozygous round and heterozygous yellow. So one, okay, two, please follow my cursor. Three, four. These are all heterozygous, right?
Yes.
Okay.
Yes.
Two heterozygous round green.
Green.
Two heterozygous round green. Okay. One, okay, because all small letter Y is green, right? So one.
Yes.
Where are the others? Two.
Two.
Can you see it?
Yes, sir. Only
Okay.
two.
Only two. Right. One wrinkled homozygous yellow. See wrinkled? All small letter R. Wrinkled. And homozygous yellow. One. So it's in here. Okay. Can you see it?
Yes, sir.
Yes.
Okay. And two wrinkled heterozygous yellow. Again, wrinkled heterozygous yellow. So the yellow here,
The
the letter Y and small letter Y.
Oh, sir, there's two.
there's two.
Okay, it's in here. Okay, one,
One, two.
two. Okay, and one wrinkled green. So
Wrinkled.
small letter R
One.
because it's wrinkled, all small letter R,
Yes.
and all small
Small letter
Y because
Y.
green. So again, our genotypic ratio, by the way, is one homozygous round and homozygous yellow. This is homozygous. Okay, please
Yes.
take a note. One homozygous round, one with homozygous yellow. Two homozygous round, heterozygous yellow. One homozygous round, green, because green is recessive. We cannot dominate, the green will never dominate the yellow. Two heterozygous round with homozygous yellow. Four heterozygous round with heterozygous yellow. Two heterozygous round green. One wrinkled homozygous yellow. Two wrinkled heterozygous yellow. And one wrinkled green. So the ratio there is 1 is to 2 is to 1 is to 2 is to 4 is to 2 is to 1 is to 2 is to 1. Again, I'll put a mark here.
1:2:1:2.
The genotypic ratio there, okay, I will write it here. Genotypic ratio is
Round
1 is to
two.
2. Okay,
I
is to 1 is to 2 is to 1 is to 2.
is to two.
Again, 1 is to 2 is to
Is to
1
one.
is to 2 is to 4.
Is to one.
To 4 is to 1, correct?
Yes.
Is
Yes, sir.
to 4 is to 2 is to 1.
Yeah, one there.
4 is to 2 is to 1 is to 2 is to 1 to 1. Okay. Again, the genotypic ratio there is 1 is to 2 is to 1 is to 2 is to 4 is to 2 is to 1 is to 2 is to 1. So if you're going to count that one, the result is how many offsprings? How many offsprings all in all? Grade 9?
Four.
All in all, how many offsprings?
16.
16, correct. Okay? If you're going to look at your Punnett square, it is 16. Okay? We going back to your PowerPoint presentation. Okay? 4, 8, 12, 16. So the offsprings there are 16. This is what we call as dihybrid cross matching. Okay? Your phenotypes or phenotypic ratio is 9 round yellow because we're looking at the physical appearance, not the genes itself, right? 9 round yellow. So how many round yellow? 9. So 1,
Yes.
2, 3, 4, 4, 5,
5.
6, 7, 8, 9. Okay, again, 9 round yellow, 3 round green. Okay, 3 round green. So, round. 1, 2.
Two.
Where's the other one?
The the second column, sir. I know.
No, 3. Okay.
Ano?
Round yellow,
Yes.
correct?
Yes.
Round green, rather. Next is 3 wrinkled yellow. Wrinkled, 1, 2,
Bottom, sir.
3.
Ay.
Wrinkled yellow. And
Yes, sir.
1 wrinkled green. So 1 wrinkled green. This one. Okay.
Yes, sir.
That's the phenotypes or what you can actually see. Okay. Again, genotypes is in the genes. What is really into the genes, and when you say phenotypes, these are the appearance or what you can observe or observable appearance because sometimes genes cannot be observed. Okay. You may carrying that one, but it is not observable. It's hidden in you. Okay. It will just manifest in your offspring or next generation. Any question with the hybrid? Please ask questions.
No,
Clarification.
sir.
Are you sure? Because after this,
Yes.
you will have your activity. I thought
Yes, sir.
that I uploaded I'm sorry for that. I uploaded the activity. Upon checking, I didn't see the activity sheet. So I just uploaded it a while ago and it is already open. Any question again with dihybrid? Because you'll be using this skill or skills in answering your activity. Question so far? Question so far? Grade 9?
No, sir.
Are you sure?
Yes, sir.
Where are the others?
Maybe disconnected, sir, because lately the internet connection is so low.
Uh,
Yes, sir.
again, my intention of recording this,
Sir, dehydration na. Two or more alleles na.
yes,
Ah,
di ba we're crossing out two or more alleles or two alleles?
yes, sir.
We're crossing out two alleles. Wait, again, I'll be sharing my screen. We are crossing now two alleles. The allele for round, wrinkled, and the allele for yellow or green. These are two alleles, right? Now, again, if you are confused with the discussion, please again visit your LMS. I'll be uploading this one. The reason why I am recording this one in order for you also to review on the lessons that you find it hard to understand or some confusing information.
Okay, sir.
Question so far? Because after this you'll be having your activity. Please
No,
inform your classmates for the activity.
What's the importance, sir, of studying the hybrid and monohybrid?
Yes, that's a good question, Margie. What would be the importance? Please turn on your camera. What would be the importance of studying monohybrid and dihybrid? This is for us to identify, again, this is for us to identify our genetic characteristics. Okay? This is for us also to know our kaliwat. Okay? That these are our lines. Okay? Sir, kaliwat man good mig high blood, but high blood is not a kaliwat actually. It is
So sir, mao din magana siya ganang mga graph sa kuan sir, mga family mong asa siya
yes,
naliwat ana.
family tree, di ba? Hilig kita magkanabitang subay. Lo, inanak bi akong lolo, inanak bi akong lola. Di ba? Masubay man ta. Right?
Yes.
Okay. Lo, akong lolo ba kay blue eyes? Di ba? Maanak man ta. Right? Di siguro na
yes, sir.
Di ba maanak man ta? That's the reason why. Monohybrid and dihybrid are really useful. Now, if you're going to look at your family tree, it is actually observable in your family tree. Okay? In your kaliwat. Even the shape of the eyes. Okay? The color of your iris, your hair, okay? The skin, okay? Color of your skin. It is genetics. And
Also sakit, sir.
the reason said behind why some of your or some of your siblings not look like you. He or she is different from you. So that's the reason behind. Remember that crossing heterozygous, di ba? If you are crossing heterozygous, you can actually see that the recessive gene, the small letter, remember the small letter, the recessive gene can only
Yes.
manifest if the other parent has a recessive of the same gene. Parehas silang recessive gene ba? Okay? If they have the same recessive,
Also kanang cancer diseases.
some of the diseases also characterized by genes. Okay? Mga genetic disorders. It can be
Yan, sir, kanang,
inherited also.
kanang albino, sir. Pwede sa na mapaspas
Albinism,
through
yes,
genes.
albinism is genetics. It can be inherited. Okay? But it is a recessive. No? It will be manifest if um the both parents has a recessive gene also for albinism. Any other questions so far? I really like you asking questions. I really appreciate it.
Sir,
Yes.
if a black person and white person mix, the offspring will be brown.
It depends upon. Um, Usually, as what I had observed, Black Americans married to a Filipino woman, usually the result is there are some brown and there are some black. Okay, remember that Black Americans is especially male. Remember male X and Y is dominant over XX because male has Y, right? Females has only X, meaning to say that males is dominant over females.
If the black, sir, is female.
If the Let me check. If black is the female, I think uh it depends upon also. If it is pure black, 3/4 or 75% of the offspring may be black. Maybe black.
There's
Why?
also probability, sir.
There
Maybe. Like maybe.
there is a probability that it can be that the offspring may be black. That's the
Even if the cancer is female, the dominant gene.
Yes, because the dominant gene is there. The dominant gene there is black, correct? But again, although we're talking about males being dominant over females, but remember also that uh, females contain also X chromosome. Okay, XX female, XY male. With regards to offspring probability, it can be answered, Margie, by crossing or using a Punnett square. Using a Punnett square in a monohybrid setting. So, di ba we're already crossing that one? Black to a heterozygous black. Okay? And black to brown. Okay? So the result, it could be that the offspring will be bringing the genes for black. Or bringing the genes for, okay.
How about in animals, sir? Just like lion and tiger.
No, you cannot mix the different animals. Why? Um, Although they belong to cat family, yes, it could be. But uh, it depends upon their genes. Remember that these animals is in the wild,
Both.
okay? And their genes may be, because of uh, the theory of uh, natural selection, theory of natural selection by Charles Darwin, it could be that their genes already change from time to time for survival purpose. Remember that the theory of natural selection by Charles Darwin talks about the elimination of the weak and the continuation of the strong. So meaning to say, those weak becomes eliminated and those strong continue their generation. It could be that
But there are ligers man, sir.
yes,
Ligers, lion and tiger.
yes, it could be that their genes already changed. And these ligers, yes, that's correct, Margie. They can because they belong to the same family, cat family. And yes, it depends upon their genes. That's what I can say. If it is pure and pure pure father to a pure mother, the result could be a mix. The offspring are bringing now the genes for that a particular allele or a liger with a tiger or a lion with a tiger characteristic or gene. It could be. So that's the beauty of genetics. That's the beauty of monohybrid cross matching because you can see now.
Only kuan, sir. Kanang creature kanang species, sir, that are in the same race kay kuan are the only ones that can kanang
Yes,
mix, just
yes, yes.
like cat and dog and dog.
Cats to cats, dogs to dogs. Because if you're going to look at their chromosomes, they have different chromosomes and they belong to different families.
How about, sir, if you try to crossbreed a dog and a cat, or
It's not
yeah, dog
possible.
and a cat?
It's not possible.
Impossible.
Sir, if ay bisan ako sir, kanang kuan sir, parang litan sir ang ilo sir kanang na pwede ba siya, ay possible ba nga maibog siya sa lain nga kuan type nga animal pod?
Mm, well, animal in nature is animalistic, but talking about mating with the other, it will never, you can never get a result. It could be that they can be attracted to some animals, but even us, no, dogs attracted to their owners. That is why if you're going to look at dogs, they're loyal to the owners or the one who fed them. Okay, but talking about results, you cannot see results in different family. Okay, like for example, you are you're talking about dogs and cats. You cannot get the result from a dog and a cat. But if it is dog to dog, cat to cat, you can see results.
Sir,
Mm.
what if in the future, sir, the genetics will change and you can crossbreed different races already?
Different races, yes. Talking about races, or if it is the same family, you can actually cross. But as of now, Margie, different species of animals with different set of chromosomes, you cannot cross them as of the moment. Okay, you cannot
Sir,
cross them as of the moment, but we can have artificial insemination, or we can actually create an organism out of their number of chromosomes or set of genes. Okay,
sir.
remember
Teacher,
the
can I ask
sexual reproduction?
uh,
Yes,
continue sir, sorry.
yes.
Can I ask a question sir that is not related to our topic? But it's part of science sir.
Yes.
Ah, does kuan sir nay core ang moon sir?
Ang moon?
Oh,
Yes, yes. There is. Of course. It's a must.
core?
Core.
Cause kuan man sir, bright side says sir ba? Kuan that sir, moon is part of the earth before the sir, then how come it has core? It's just part of
Part
the
of the
earth.
earth. Why do you say so?
I just kuan sir saw it in bright side.
Part of the earth. If it is part of the earth, then how does the earth form? Now, you need to think about it. Uh, Again, this is not related to our topic, but I will just answer the question. With regards to the formation of the earth, it's in the Big Bang theory, right? The blasts. Okay. And remember the theory of the law of motion by Newton. Okay, you review the laws of motion by Newton and review also the Big Bang Theory because it explains how the Earth is formed and the moon, Luna, our moon, is it is not classified as part of the Earth. So again, Luna is not classified as part of the Earth. Okay, it is one of the celestial bodies. When these celestial bodies, these